How are you, my dear children? Hope you all are safe and fine. Today we are going to discuss lots of graphs. We'll discuss graph of electric field versus distance. That means we are going to discuss, or we are going to see how electric field varies with distance. What we have studied till now, suppose a Q charge is over here and I want to find out the electric field over here, which is at distance r. Suppose this is plus Q charge is placed over here. So at this point the electric field will be how much? We know electric field E will be kq by r square, and the direction of the electric field will be like this. Sorry. Why? We know for positive charge the electric field is always away from the positive charge. Clear? Suppose minus Q charge is over here and I want to find out the electric field over here, and it is at the distance r. So for this minus Q charge, what is the electric field? E will be same kq by r square, and here the electric field direction will be towards the negative charge. This thing already I have told several times. When positive charge is there, your electric field will be away from the positive charge, and when negative charge is there, your electric field will be towards the negative charge. Okay, you can now see from here this formula. E is inversely related to r square. That means if we want to find out the electric field just near the charge, then distance is very less. So when distance is very less, that means your electric field intensity will be more. So when r is less, electric field intensity will be more. Now we'll keep on increasing the distance. So when r increases, that means at the far off place, if I want to find out the electric field, that means if distance increases, what will happen to the electric field? Electric field intensity will decrease. Okay, that means if r tends to infinity, your electric field intensity will be obviously tends to 0. Clear? This much also we have discussed. Now always we consider the point charge. Do you know this? Already I have been telling this thing. You will consider point charge only. Suppose a charge sphere, whether we will consider it as a point charge? We can consider sphere as point charge also, children. How? We can treat it as a point charge. How we will treat it as a point charge? When we will find the electric field far away from this sphere. That means distance is very large. Then from far off distance, this sphere will look like a point charge. This sphere will look like a point charge. So from the far off distance, if you are calculating the electric field at infinite distance, you can say at very large distance, then you can treat this sphere as point charge. Is it clear? Then how the graph will be? Let us see. Let me clear the board. See, children, what we have seen now, electric field is inversely related to this r square. So that means if we take electric field in y-axis and your distance in x-axis, we have to take electric field in y-axis and distance in x-axis, then you will get a graph like this. How? Because when charge is over here, so near to the charge, electric field is very large. So you can see, suppose charge is over here. So near to the charge, initially the electric field is more. So it is almost like parallel to your y-axis. Because it is almost infinite. Your electric field is almost infinite since r tends to 0. When you keep on increasing the distance, your electric field will keep on decreasing. And when r tends to infinity, at the far off place, your electric field tends to 0. Clear? How we are getting this curve? Now, for plotting the graph, there are some rules. What is the rule? First rule. Rules to plot the graph. If electric field is in right direction, if your electric field is in right direction, then we will plot electric field in positive y-axis. In positive y-axis. If electric field in towards left, if electric field directed towards left, here directed towards right, we will plot electric field in negative y-axis. Remember these two rules. Clear, children? Now we'll see one by one. We'll discuss some examples. Clear, children? First example. Suppose a plus q charge is over here, children. So this is plus q. We know for plus q, now let me draw the axis, then it will be easy. So plus q just over here, just near the charge, here and here. Tell me the electric field. We know for positive charge, electric field will be away from the positive charge. Here also, at this place, your electric field will be away from the positive charge. Clear? Now, come over here. So when we are keeping the, or we want to measure the electric field at this point, so it is just near to the charge, the electric field will be maximum. And what I have told you in the rules, so electric field direction is towards right. So towards right means we will plot the graph electric field in positive y-axis, and just near to the charge, electric field will be maximum. And when you will keep on increasing the distance, your electric field will decrease. Is it clear why you are plotting the graph in positive y-axis? Since your electric field direction is towards right. Now come to this point. Come to this point. Now electric field direction is towards left. What I have told you, if electric field direction is towards left, then we will plot the graph in negative y-axis. Now just near to the charge, your electric field will be maximum, and as the distance increases, your field also decreases. Is it clear now, this graph? For electric field, when it is in right, we will plot the graph in positive y-axis, and when it is towards left, we will plot the graph in negative y-axis. Clear? Now second. Second graph. Now I will take minus q. So let me draw the axis first. Okay. So this is your electric field. Now minus q. Minus q, I want to just measure the electric field near to the charge. Near to the charge, for minus q, what will be the electric field direction? It will be towards. It will be towards the negative charge. Now come over here. Here at this point. Again, it will be towards the negative charge. Clear the direction of the electric field. Now we'll try to find the where the electric field is maximum and where it is minimum, so that we can plot the graph. So when the electric field is towards left, that means it will be in negative y-axis. Clear children? It will be negative y-axis, and just near to the charge, your electric field will be maximum, and as the distance increases, your electric field decreases. Clear now? Come over here, this point. Here also. Now it is towards right. Towards right means it is in positive axis. We'll plot the electric field in positive axis. Again near to the charge, electric field will be maximum. So it is almost infinite. As the distance increases, your field also decreases. Got the plot? E versus distance, electric field versus distance for negative charge. Clear? Now we'll see when two charges are there, how we can plot the E versus distance curve. Suppose now here plus q, okay, now here another plus q is charge is over here. Clear? Now plus q, see plus q means just near, we'll see plus q means your field will be away from the charge. Here also field will be away from the charge. Now you are expert, you can do immediately. Here also for this charge, plus q means away from the charge electric field, plus q means electric field is away from the charge. Okay. Now see here the electric field is in this direction, and here the electric field is in this direction, and we know both the charges are equal, plus q and plus q. That means the magnitude of the electric field will be same, but they both are in different opposite directions. That means somewhere in the middle you will get a null point. You will get a null point where your electric field will be 0, because both the electric field will cancel out as they are equal in magnitude and opposite in direction. So that means at this point your electric field will be 0. Now let us see how to draw the graph. Now for plus q, the electric field over here, we are considering this point now. So it is in electric field direction is towards right. So towards right means obviously it is in positive y-axis, and just near to the charge your electric field will be maximum. So it will keep on decreasing and it will become 0 since it is cancelling out. Clear children? Now for this point your electric field is, now you can see at this point to the left of the charge your electric field is towards left. So towards left means simply we will plot in negative y-axis. Just near to the charge your electric field is maximum, so it is almost parallel to the axis. Infinite, your electric field is infinite, and as the distance increases your electric field decreases. Now come to this point. Okay, here it is towards the left, you can see. Come to the second charge, it is now towards the left, as you can see. I am keep on doing this. It is towards, so it is in negative direction. So negative direction means towards left means not negative, it is towards left. Towards left means we have to plot the graph in negative y-axis. So near the charge your electric field will be maximum, and as the distance increases, one second children, please draw these graphs like symmetrically. Do this graph, because for me it is getting difficult. So now it is maximum. So now it will decrease and it will intersect like this. Because what we have seen the electric field will keep on decreasing as the distance from the charge increases. Clear, children? It will be like this. Is it clear? So little bit fine. Now graph. Now see, come to this point now. Now your electric field is towards what? Electric field is towards right. Towards right means it will be in positive axis. So your graph will be near the charge, it will be maximum. Then when the distance increases from the charge, your electric field will be minimum. Clear? So distance is less means your electric field is infinite, as you can see. And as the distance increases, as we move far away from the charge, electric field decreases. Clear this? Okay? This plot I think clear? Okay. Now we'll see the next graph. I think this one is the fourth graph. I'll take now two charges, minus q over here and minus q over here, children. First we'll draw the axis like this. Now minus q just near the charge, electric field will be maximum. Okay, we know that minus q means your electric field direction will be towards the charge. Here also it will be towards the charge. Come to the this charge, second charge, right hand side charge. Minus q, again the electric field will be towards the charge. Here also electric field will be towards the charge. Clear? Now since minus q and minus q, as you can see, both the electric field direction is in opposite direction, but they have equal, you can say same electric field since both the charges are equal, minus q and minus q. So your electric field will be same, the magnitude will be same, but direction is opposite. That means they will cancel each other. They will cancel each other at the midpoint. So here this is your null point where E is equal to 0. This is your null point, children, where E will be 0. That means at this point your electric field will be 0. Now we'll see how to plot the graph. See, children, now it is towards, electric field is towards left. What I have told, if it is towards left, your electric field will be in negative y-axis. So we will plot the graph in negative y-axis and it has to be 0 over here. Clear? Now come to this. As you can see, now electric field is again towards right. Towards right means we will plot the graph in positive y-axis, and we know to the near to the charge, electric field will be maximum. As the distance increases, electric field decreases and it will tend to 0. Clear? Now come to this point. Your electric field, you can see towards right at this point. Towards right means it will be, electric field will be in positive y-axis, and since electric field is 0 at this point, that means your graph will intersect like this. Come to this point now. It is, electric field direction is towards left. Towards left means just in negative y-axis. Clear, children? This graph. Now to the near to the charge, electric field is maximum. As the distance increases, as we are moving away from the charge, your electric field will tends to 0, it will decrease. Clear, children? Now we'll discuss the next graph. Graph number 5. We'll take now what we have seen, two charges of the same nature. Now we'll discuss with the different nature charge. Suppose it is plus q and it is minus q. Then how the graph will be. See, children. Now, for positive charge, what is the electric field direction? In which direction? It will be away from the charge. Here also it will be away from the charge. For negative, it will be towards the charge. It will be towards the charge. Now we know the things, we can do it easily. Just near to the charge, electric field will be maximum. Now we'll try to plot. Electric field is maximum. See, it is plus Q like this. And here also, your electric field is like this direction. Do we, just tell me whether we'll have the electric field 0 in between these two charges, how we are getting in previous two cases? No. Here will not get electric field 0 at any midpoint, say children, because both the electric field are in the same direction over here. So there is no null point in between these two charges. So how the graph will be then? See, if you appear plus Q, it is like this. So near the charge, it will be maximum. Then it will keep on decreasing, but here it will not be 0. Now come to this point. It is towards left. Towards left means again the plot will be in negative y-axis like this. Now come to this point. Here it is towards right. Towards right means positive y-axis, and the electric field will not be 0. So graph will be like this. Okay. Please do the graph symmetrically. Now it is towards left. Towards left, electric field towards left means what will do? Negative y-axis like this. Is it clear, children? The graph? Okay. Let me clear the board. Now we will do the next type of graph. Graph number 6. Now till now what we are discussing, plus Q minus Q plus Q plus Q, equal amount of charge, equal value of charge. Now we'll take one charge as plus Q over here and plus 4Q over here. Then what will happen? Do the axis like this, joining the charges this line like this. Plus Q, it will be, electric field will be away. No more discussion is required. We know the things. Now you have understood the things. Plus Q, plus 4Q, away. Now we know same charge. That means there will be some null point somewhere in between plus Q and 4Q. But since there in previous cases it is plus Q or minus Q minus Q, we used to get electric field at the middle of the lining joining the two charges. Now here amount is over plus Q, here plus 4Q. So where we get a null point? Remember children, we have already discussed this thing. Null point is always near the small charge. That means somewhere near the here will get our null point. Electric field will be 0. Remember this. Now we'll draw the graph. So here electric field will be away, and as you can see here electric field is 0. So your graph will be like this. Okay. Let me draw more neatly. No, this is not nice. Let me clear it out. See children, near to the charge electric field will be maximum, then it is becoming 0 over here. Now come to this point. It is, now electric field is towards left. Towards left means it will be in negative y-axis, and near to the charge it will be maximum. Then as we keep on increasing the distance, it will change to 0, it will decrease. Now come to this point. Here plus 4Q, it is towards left. Your electric field is towards left. That means it is in negative y-axis, and we know now the graph will intersect since it electric field 0 over here. And here it is towards right. So simply the electric field will be like this children. Okay, near to the charge electric field will be maximum. Then as we keep on increasing the distance, your electric field will be 0. Is it clear children? Remember one point. I'll write it as a note. The null point is always near the smaller charge. Remember this. This is very important. Okay. Now we'll discuss our last graph. We'll discuss. Suppose I will take plus, you can say, no, let me take dissimilar. Okay, dissimilar charge. Suppose I will take what we have discussed now, q plus, now I will take negative charge. Let me take negative charge. So minus hq. Here I will take minus 4q. Then how the plot of the E versus R curve, that is electric field versus distance graph, will be. Now minus HQ, minus means electric field will be towards the charge, here also towards the charge. Now minus 4Q, here also towards the charge, here also towards the charge, since negative charge. Now tell me where the electric field will be 0 or where we will get the null point. We know null point is always near to the negative charge. So here you will get your electric field 0, near to the charge. Now come to this point. Your electric field is now towards left. Towards left, near to the charge, it will be maximum, and as you keep on increasing the distance, the electric field will be decreasing. That means here at this point we will draw the electric field in the negative y-axis. Since it is towards left, now it will intersect, because here electric field is 0. Clear? Now it is, tell me, it is now towards right for this. So towards right means the electric field will plot the graph in positive y-axis. Here electric field is becoming 0, so it will intersect like this. Clear, children? Okay. Now come to this point. Now your electric field is towards right. Towards right means positive y-axis. Your graph will be like this. Here it is towards left. Towards left means your graph will be in negative y-axis. Is it clear, children? All types of graphs. You can keep practicing these graphs. These are very interesting, and it will clear your theory, the concept what we are studying till now. Okay, and this is very, very crucial for your entrance also, and for exam definitely, but for entrance JEE and NEET, these graphs are very, very important. Hope you have understood this lecture. If anything, just let me know. Please leave a comment in comment section box so that I can address your doubts if anything is there. Okay, and take care, children. Thank you for watching.